Hello everyone, welcome to my channel. It's called For Kids because I'll try to explain everything by using simple concepts. In this video, I want to tell you how to work with docker-compose. We will run a simple Spring Boot Java application which connects to Postgres in one container and run the Postgres database itself in another container. Also, we will see how to work with Docker volumes. I highly recommend it to watch first video about Docker on my channel for better understanding. Almost every time, when we're running a Docker container, we need to specify a set of parameters such as ports, container name, environment variables, and so on. But what if we need to start multiple containers and wire them together? Of course, you will need to specify lots of parameters in every container, which is quite difficult and it's easy to make a mistake. To solve this problem, there is a docker-compose. Docker-compose is the next abstraction level of Docker. It's the tool which helps to run multiple containers with writing all configuration in one file. With Docker-compose, you can configure running a single container as well. Okay, let's move to practice. Before start, I want to show you what our new demo Java Spring Boot application does. Our application connects to Postgres database, so at first we need to configure the Postgres. We can do it by running a Docker container with Postgres inside and connect our app to this Postgres. Let's do it. We need to run the command docker run -d detached mode -rm -p 5433 5432 name Postgres -e Postgres password equal Postgres and the name of the image. -rm means that our container will be removed after stopping. I use port 5433 just because on my local machine default Postgres port 5432 is busy. Name of a container, and we need to specify an environment variable Postgres password to start this container. As we see, our container started. Let's look in Docker desktop. Yeah, it's running, it's okay on the port 5433. Now, what we need is to run our application. Let's do it. But before running, we need to locate our terminal to the path of our application. For starting this, we need to specify a couple of parameters to connect to our database. To do this, I need to write -d spring data source URL equal jdbc postgresql //localhost 5433 Postgres. Next, else one property spring data source username equal Postgres -d spring data source password equal Postgres -jar docker postgres.jar. Let's try to start it. And as you can see, everything is fine. Our application started on port 5000. Let's look at it. Localhost 5000, and we see that now our app show us index page with the table of customers, and when you refresh the page you can see that a new customer is added to the table. Now we have one problem, that the information inside the database stores only while container is running. Let me show it to you. If we will stop our application by pressing the shortcut Ctrl+C. Next, we'll stop the container, docker, stop postgres. We see that there are no container, and let's restart this container. Okay, it has started. Now let's rerun our Java Spring Boot application. Okay, now if we will refresh the page, we will see that there are only one row in a table. To solve this problem, we can use special tool Docker volumes. What is a Docker volume? It's just a folder on a local machine which is located on a special path. So we need to create a Docker volume and wire it with a folder inside our container. Let's stop our application. Let's stop our container. Okay, and let's create a volume. Docker volume create postgres, we write the name postgres underscore volume, and we can look which volumes do we have by writing the command docker volume ls. And as we see, we have only one local volume with name postgres underscore volume. Next, we need to run a postgres container and define volume. To do this, we find our command and add special tag -v with name postgres underscore volume. Let's start it. Oh, I made a mistake. Sorry, I forget to do one thing. We need to print colon /var lib postgresql /data. What is this? It is a special path inside the container. This path you can find on an official page of the Postgres container on the Docker Hub. And if we will try to find word volume, we can see this path in here. Okay, now let's run the container. As we see, it has conflict because our container is already running. Let's stop it. Docker stop Postgres. Okay, it's removed. And now finally let's run and see that everything's fine. Let's restart our application. Wait for a couple of seconds. Refresh our page and see here only one row in the table. Let's add a couple of rows. Now let's stop the application. We will try to refresh our page. Nothing will happen. Now let's stop the container. Docker stop postgres. It stopped. As in previous example, let's rerun the container. It's okay. Run our application. It started. Refresh the page. And we see that our information was saved. Okay, we have prepared for showing how does Docker Compose work. Note that Docker Compose is included in Docker Desktop. So when you install Docker Desktop, you already have Docker Compose tool. To run our app in one container and Postgres in another container, we will use Docker Compose. To use it, we need to create a file with special name docker-compose.yaml. As you see, I already have this file. Let me remove it and create it from scratch. docker-compose.yaml. Note that this name is special. You have to write it correctly. Let's open the file and write. Firstly, we need to specify the version of the Docker Compose. Version, column, let it be 3.8, it's the last version for today. Next, we need to specify volumes. We have volume, Postgres, volume. It specifies local volumes. services. Next block is services, where we define our container configuration. First container would be DB container. We will use image postgres latest. Image postgres with latest version. We'll use the volume postgres volume colon var lib postgresql data, as we have done previously in the command line. Next, we need to define environment. Postgres password. Okay, and we finished with the DB container. Next would be the Docker test container. Oh, I forget for one thing. Let's define the container name. Maybe it's unnecessary, but if you will not define it, docker-compose will generate it by itself, and it would be not so beautiful. Next, we define Docker test. It will be created not from the image, but from the Docker file. To do this, we need to write command build :dot. Dot means that a Docker file is located on the same path with the docker-compose.yaml file. Let me show you the Docker file. It is absolutely the same as the file from the previous video. We just get the OpenJDK image and copy the docker postgres.jar file inside it, and after that we run our application. We say docker build container name :docker test. We need to specify ports. It would be 5000 on 5000. Next important block is depends on. We have to define that this container will depends on DB container. For starting our application, we need already started Postgres container. Next, we need to specify all environments by writing this Spring data source URL :jdbc postgresql db. As you see, we use not localhost but db. It's a name of our container. Port 5432 Postgres. I want you to understand that we didn't specify the port in the Postgres container because it would be by default 5432 and would be available only inside our bunch of containers. Note that this port would be unavailable from outside. Next environment, Spring data source underscore username Spring data source underscore password Postgres. Okay, and last would be tz Europe Moscow, and let's add one flag: restart always. It means that our container Docker test will restart every time when something went wrong. I found a little typo here. Yes. Now let's run our Docker Compose containers. Docker Compose up. And as we see, our image is built from Docker file. Successfully started. Let's refresh the page, and we see that here are a couple of records in the table. Everything's working. But now, in the console, we are inside a Docker Compose project. To quit from it, we need to stop our application. To do it, press Ctrl+C. Okay, if we want to run our Docker Compose project in background, we need to start it with familiar to us flag -d, which means detach mode. Docker compose up-d. Done. And as we see, our Docker Compose started. Everything's working. But now in command line, we are not inside a container. If we want to see what is happening inside our container, we can run the command logs. Docker compose logs -f. F means follow. And as you see, we see logs. For now, if we will press Ctrl+C, we will exit only from logs following, but Docker Compose project will continue working as you see it inside a Docker desktop. Note that all Docker Compose commands are executed in terminal, applied to the project launched by the docker-compose.yaml file, which is located on the same path where the terminal is launched. Now, what if we need to rebuild our project? For example, you update your jar file. Let us change the jar file from which our container will be created. To do this, let's go to Docker file, open it, and let's replace the name of the jar file here. It will be docker test. Docker test.jar, it's exactly the same application from the first video. For now, we have a running Docker Compose. To stop it, we need to write docker compose down. Okay, now we see that there are no containers. And if we will run our Docker Compose up, and wait a couple of seconds, we see that nothing changed. Our application didn't change because Docker Compose started from existing images. So for update our image, we need to down Docker Compose. Let's stop our Docker Compose down. We see that containers removed, and rerun our Docker Compose with special flag build, and we need to build our Docker test container. Okay, let's refresh the page, and everything's working fine. As we can see here in images, we have strange image with known tag. Images like that left when Docker creates a new image with the same tag. Docker just doesn't know how to name it and left it with known name. To remove images like that, we can execute special command. Let's stop. It command would be docker system prune. Yes. And as we see, image with tag none were deleted. What if we don't want to run this command every time and don't want to left containers with known tag? We can down the Docker Compose with special command docker compose down -rmi. It means remove image. Local. Local means it will remove images which were built locally on our machine. And also we can print -v flag, which means to remove volumes as well. Everything's fine. And now if we will print docker volume less, we see that there are no any volume we have for now. Or we can just manually remove images which we want to be updated. And for now, we have learned how to refresh containers inside Docker Compose project. Else one topic which I wanted to tell you is how to run our Docker Compose on a remote server. So if we want to do it, we need to have all of our containers on the Docker Hub. In our case, we built Docker test container. Let me show it to you. We built Docker test container from the Docker file, and we can upload it to the Docker Hub by the way, as we have seen in previous video about Docker. And then we will need to write here not build but image and the name which we will use, like for example like this, which is specified on the Docker Hub. So then all you need is to copy your docker-compose.yaml file to the remote server, open the terminal and write a command docker-compose up, and your application will successfully start on remote server. I think it's awesome. We have come to the end. Today we have learned how to work with Docker Compose and Docker volumes. So now you can create more complex projects based on several containers at once. Don't be upset if something does not work out for the first time. A little bit practice and everything would be fine. In next videos we will continue to learn technologies together. Please write to me in the comments what you liked in this video and what can be improved in your opinion. Thank you for watching this video, hit the like button, and if you want to see more, make sure you subscribe to my channel. Have an awesome day, and I'll see you once again in the next one.